Good morning, dear students. So as we were doing the differential equation, and in the last lecture I have explained you about the type reducible to variables is separable, where we have seen that we are given with some differential equations and we found the solution of it. Okay, by substituting some functions from our the main differential equation as v, and we have done those questions in the last lecture. Okay, now we are coming to the next topic, and that is very important for you, that is called the homogeneous differential equations. Let us first know the meaning of homogeneous, as if we find the general meaning of the homogeneous, which means identical, or which means, or in the other word it says look alike, that is called the homogeneous differential equation. So let us consider one equation, that is fxy is equal to 3x minus 5y, or let us consider another function 5x square minus y square. One more. These three equations are homogeneous equations, not the differential equation I'm saying. They are homogeneous equation. Why? Because, say for example, if we are taking this equation, here the degree of this x and degree of this y is same. If you see this equation, here the total degree of x is 2 and the total degree of y is 2, hence this is also called the homogeneous equation. In this, the degree 1 plus 1 what 2, and here also 2, 1 plus 1 2 and 2. This is also a homogeneous equation. So a function is said to be homogeneous function of degree n if their total degrees are same. Here the total degree is 2 and here the total degree is 2. Here also 2 2. Here 1 1. That should be same. That is called the This is, I'm giving you a very general idea of homogeneous equation. Now we will come to the homogeneous differential equation. Say for example, I'm writing dy dx is equal to 2x minus y upon x plus y. Is that a homogeneous differential equation? So yes, this is a homogeneous differential equation. Okay. Now after detecting the homogeneous differential equation, we are coming to how to solve the homogeneous differential equation. So there is a proper criteria of solving it. What we do, we put y is equal to vx in our main differential equation. Okay, so first put y equal to vx, then we differentiate it with respect to x. Okay, so we get dy dx is equal to this. Here we'll be using the product rule, so v plus x dv dx. So in the function we put y equal to vx, and in place of dy dx we substitute this equation, and then we reduce it, and we use variables separable method, as of we have seen in the previous lectures. Okay, so with this we are starting the questions of this homogeneous differential equations. Okay, so this is the first question. Solve the following differential equation. You are given dy dx is equal to x plus y upon x. Okay, so as this is a homogeneous differential equation, why? Because the total degree of x and y, they are same. Okay, so let us start solving it. First, what we can do, we can just separate. If you could simplify, no, just try to simplify it. Okay, y upon x. Now what? As I told you that for solving the homogeneous differential equation, we put y equal to vx. Differentiate both the sides with respect to x, so you'll get dy. I'm differentiating this equation, all right. Okay, so in place of y we can put vx, and in place of dy dx we can put v plus x dv dx. So substitute it. On substituting, v plus x dv dx is equal to 1 plus vx upon x. So x to x it gets cancelled. V plus x dv dx is equal to 1 plus v. Again, what we can see that here v to v can also get cancelled. So take x that side. So we'll get dv dx is equal to 1 minus x. Take dx that side. So dv equal to 1 minus x dx. On integrating both the sides, integration of dv is equal to integration of 1 minus x. What will be the integration of dv? It will be v only, because integration of 1 is 1, it will be v. If you are integrating with respect to v, 1 integration is x minus x square upon 2 plus c. Now again, what you can put in place of v, we can put y upon x, because as our question is in the terms of x and y, so we need to just replace v with y upon x. So y upon x is equal to x minus x square upon 2 plus c. More you can do is take x that side, so y will be equal to x square minus x cube upon 2 plus cx. Okay, like this we have to do this exercise questions. Okay, so let's understand the next question. That is, here we are given with x minus y into y dash. Here y dash is dy dx, x plus 3y. So let us arrange it properly. Y dash is equal to taking x minus y in the denominator, putting y equal to vx, or v will be equal to y upon x. That will be helpful in the last step. Differentiate both the sides with respect to x, so y dash will be v plus x dv dx. We can replace this y dash with this value, so v plus x dv dx will be equal to, in place of y I have written vx, and here also vx. I've taken x common from the numerator and denominator, cancelled it. We are left with 1 plus 3v upon 1 minus 3v. Now taking v that side, so minus of v. Take LCM, so it will be minus of v plus of v square upon 1 minus v. Now on solving this, we are getting v square plus 2v plus 1 upon 1 minus v. This can be written as v plus 1 the whole square upon 1 minus v. Take 1 minus v that side, so 1 minus v upon, I'm writing this v plus 1 as 1 plus v the whole square, which can be written x will be that side and x will be in the denominator. Okay, now in the numerator I'm subtracting 1 and adding 1. Why? So that I will get, I may get 1 plus v, and when I separate this 1 plus v the whole square with the numerator, one thing should be cancelled. So that is why we're using this logic, that subtracting 1 and adding 1 in the numerator. So this 1 plus 1, first of all 2, and then among these two I've taken minus common, that is 1 plus v upon 1 plus v the whole square dv dx. Now after that, what will happen? See, on separating we'll get 2 upon 1 plus v the whole square minus, and here 1 plus v dv equal to dx upon x. Now integrate both sides. On integrating both the sides, integration of 2 upon 1 plus v square minus 1 upon 1 plus v dv dx upon x. Here this the integration of this will be, it will go up, 1 plus v the whole square, it will go up, it will be 1 plus v to the power minus 2. So minus 2 plus 1 upon minus 2 plus 1. So finally we'll get minus of 2 upon 1 plus v, isn't it? Because minus 2 plus 1 will give you minus of 1, so it will again go in the denominator, and this minus sign minus. Here the integration will be log 1 plus v upon 1 plus v. What will be the differentiation of 1 plus v with respect to dv? It will be 0 plus 1, so we don't write that thing. Okay, it is understood, and it will be log of x plus c. All right. Now what you do, in place of v, just write y upon x. So minus 2 upon 1 plus v minus log 1 plus y by x is equal to log x plus c. Okay, take the LCM and just use some properties of log. Okay, in place of this also y upon x. See, what I have told you before also, in this differential equation chapter, your answers may or may not match with the answer key which is given at the last. Okay, but don't worry in this respect. Why? Because see, there are different ways of solving or simplifying the things. Even in our life, we deal with certain problems and situations in our own level and in our own mindset. Okay, so that is what, see, after this step, this can be solved in many ways. Okay, so it depends on you, how do you solve. Okay, don't try to match it with the, maybe with the at the back it may be different in your answer, but please make sure that your way, that means the criteria and the steps, should be correct. Okay, it should not be wrong. Otherwise, if you do any mistake here and you expect that okay, my answer is not matching with the back, and as I said that it is okay, so it will not be okay at that time. Okay, so please remember this thing. So here is the next question. We are given with x dy dx is equal to y bracket log y minus log x plus 1. So let us first simplify it. How we are doing, take x in the denominator, so it will be y upon x. Okay, and here I've used one property that log m minus log n is log m upon n. That is why log y minus log x is log y upon x plus 1. Again, let y equal to vx, as this is a homogeneous differential equation. Okay, so consider y equal to vx, so y upon x will be what, v. On differentiating dy dx will be v plus x dv dx. Okay, so in place of this dy dx, we have substituted by v plus x dv dx. In place of y upon x, v, and here also v plus 1. Multiply v inside, so v log v plus v. This v to this v we can cancel. We are left with this thing. Now take v, all the variables of v one side and x another side. So dv upon v log v, and this is dx upon x. Now we know how to deal with this thing. For this, let us consider, let log v equal to t. So 1 upon v dv equal to what, dt. Alright, so on integration, we have considered log v equal to t, so 1 upon v dv equal to dt. So in finally, what we will get, dt upon t equal to dx upon x. So log t equal to log x plus c. Okay, so in place of t, again you put log v. So log v equal to log x plus, this c you can consider as log c also. Why we are doing so? Because, okay, so because this is a constant term. Okay, so this c can be considered as log c also. Why I'm considering log c? Because log to log can be easily cancelled, because here we have log v, and this log x plus log c, it will give you log x into c. Why? Because log m plus log n is log m into n. So this is why, that is why this log and this log, they can be self-adjust, and we'll get log v equal to x into c. Okay, so this is also how you can see, I told you, our way of solving. So log v equal to x into c. Now again, in place of v, we can put like this. Again, you use the property log y minus log x equal to, sorry, log will not be here, xc, take minus x that side. So log y equal to xc plus log x. Now, if you want to remove this log, take exponential both the sides. So on taking exponential also, see, this can also be the answer, this can also be the answer. Okay, even you can leave your answer up to this at this step also. All right, until and unless they say that prove this thing. Okay, so like this you have to do. So dear students, in the next lecture we will come up with the same exercise and more questions. Okay, and maybe if possible we'll start the linear differential equation in the next lecture too. Okay, we'll do more questions of it, don't worry, for this exercise. Okay, so till that, do a good practice. I expect you will do it. Okay, thank you so much, have a nice day, bye bye.